Today's video is going to talk about chromatography. In particular, it's going to go into detail about how ion chromatography works. So chromatography in general, we are looking to separate the components of a mixture. When I say components, I mean different types of substances within that mixture. And we always have a stationary phase, that's usually a solid, and then a mobile phase, that's either a liquid or a gas, that goes and travels along the stationary phase. In this case, this stationary phase has hydroxyl groups attached to the surface, so it would be a polar stationary phase, meaning that this mobile phase would have to be a non-polar mobile phase, because the idea is that we're trying to separate mixtures based on their polarity for the majority of the types of chromatography we're looking at. And so looking at these three different molecules, this is the least polar, this has got a little bit of polarity, and then this is the most polar. And so the idea is, if we're trying to separate them out, the most polar substances are going to be attracted to the polar stationary phase, so they're going to travel very slowly along because it's going to have strong secondary interactions with the stationary phase. Whereas this molecule, so this is ethane, it's very non-polar. It's not going to be attracted to the stationary phase very well. It's going to travel with the mobile phase quite fast because the mobile phase is a non-polar phase, and so we say that it's going to be less adsorbed to the surface of the stationary phase. Adsorbed meaning it's stuck to the outside rather than absorbed into the stationary phase. And so then if those three components of a mixture were put in, this molecule would take the longest to travel through, this one would travel a little bit further, and then this one would travel the furthest. If we were doing this as TLC, as thin layer chromatography, we would get some sort of played out that looks a bit like this, whereas if we were doing GC or HPLC, we'd get out a chromatogram that looks a bit more like this. Ion chromatography is a little bit different because ion chromatography is looking to separate out the components of that mixture based on the charges of the particles in the mixture. And what happens is we have some sort of column to start with, and that column is full of plastic beads. So we call them polymers, so polymer beads, resins, and while I've drawn it here with some space between them, the idea is they would be very tightly packed. Now these beads need to have a charge on them, so you can either have resin beads which are positively charged throughout, or you can have beads that are negatively charged throughout. Can't have both of them mixed together because the idea is we want to separate out the charged particles, whether they're negative or positive. If you have a negatively charged resin going through, the ion chromatography will start off with some sort of other ion attached to the outside of the bead, and this will normally be some sort of sodium chloride solution. So for a negative resin, you would have some sort of sodium particles just spread out through the resins and attached to the resin, whereas if it was a positive resin, you might have the chloride ions throughout. And so that would look something like this. So all of these sodium particles are attached to the outside of our negative resin, and then when we have our mixture, which could be containing a variety of different things, so we've got some negative particles, we have some positive particles, and then we've got some positive particles that are actually 2+ as opposed to 1+. This whole mixture is going to be added into our column, and it's going to travel down past the resin beads. And when that happens, they're going to interact with the resin in different ways. So as you can see here, the negative ones are not attaching to the resin, they're just flowing throughout because they don't really want to attach to these negative charges, whereas the positive, both types of positive ions have attached to the resins and taken the place of the positive ions that were there before. So we also call this ion exchange chromatography because the idea is that the positive ions in our mixture are going to take the place of the ions that were already attached to the resin, and then as the mobile phase passes through, it's going to travel down at different rates depending on the charge, but also the density of the charge, so whether it's a 2+ or 3+ or 1+. So a 2+ will have a much greater affinity, which means attraction to the negative charges compared to the 1+. And we'll see that as we go on. So this is just an enlarged version of that. So as the mobile phase travels through, these negative particles have moved faster than the others. They're heading down the column, The positives have moved a little bit, but the idea is that as they move down, they're getting attracted to our resin again, and the ones with the double plus haven't really moved at all because they're more strongly attracted to these negative particles. And then as it goes down further, the negative particles are getting close to the end of the column. Positives haven't moved that much, maybe a little bit, and we're also getting those positive sodium ions that were originally attached to the resin, so the green ones are moving down as well as they're being exchanged with the other ions that in the mixture. So now our negative ions are starting to come out of the column, and so if they're coming out, we can collect them into some sort of container, and this is how we're separating out the components of the mixture for ion chromatography. So a little setup that's very similar to the burette in a titration, so we can allow the negative particles to come through. There might be some sodium particles as well from our resin, but as we know, sodium is very, very aqueous or soluble in water, so they will be easy to remove from these negative particles when we want to get just the negative particles. As we can see as well, those double positive ions haven't traveled very far, and the single positive have moved a little bit. So now just moving on a bit more, we've got all of our negative particles out, so we can almost say that we've got our band A or our component A separated out, so we can probably even just take that away, while our next lot of component that we want to collect out, the single positive charges, have moved down further in the column. Our double plus ions still haven't moved very much, but they're slowly making their way down the column. So now just sped it up a little bit. We've got our component A, and our component B has basically come out, so we're collecting these single positive ions into another separate beaker. That way we're keeping it separate to the one before. Our double positive have moved a little bit further, but again they're moving very slowly because they're more strongly attracted to that resin compared to the single positive. And then if we keep going, we've got all of our positives in there, so we can move that aside and make way for our double positive ions as they eventually come through. So this can actually be a very long process, waiting for all the mixtures and all the bands to separate out in ion chromatography through the column, and so we just need to have a little bit of patience while this happens. So here we're starting to finally get our double positive ions coming through, and eventually as much of that will come through as possible. As you can see here, there's still actually, I've left 2 in there because depending on what our mixture is, there could still be some positive ions left on the column at the end. Now there is a way to get that out, so if there are any left over, we can flood the column with more of those sodium ions that we had before, and that way the sodium ions will go down and they'll exchange with the double positive in order to flush them out. But really we would want to be doing this anyway, because as you can see, our resin looks nothing like it did when we first started, and if we want to use this column again to do another ion chromatography, we're going to have to, it's called regenerate the column, and so fill up the the positive charges around all of our resins. So we add in those sodium ions, they're going to go through, they're going to flush down through the column, and those last few particles can come out. Just zooming in a bit, so now that we've got the last lot out and we've replenished all of our positive charges onto our resins, ready for the next one, we're done with our ion chromatography. So just a summary for that, we started off with a column which had just positive ions on the resin. We added in our mixture, and the mixture separated out the different components based on whether it was a positive or negative charge, and then based on whether it had a greater amount of positive charge, so a 1 positive or a 2 positive. So the 2 positives moved a lot slower down the column compared to the 1 positive. Okay, thank you for watching, and put any questions that you might have in the comments.